Welcome to the translation lecture PowerPoint. Here the learning target is for you to understand how a figure translates in a coordinate plane. The success criteria are three. 1. I can identify and construct the vector. 2. I can relate the characteristics of a vector to a translation. And 3. I can construct the general rule for a translation. The first thing we're going to do is do the exploration. You're going to translate a triangle in a coordinate plane. Here, this is your triangle, and you're going to perform a translation. Do these three things. Part A, the point x comma y is translated A unit horizontally and B unit vertically. You're going to write a rule to determine the coordinate of the image x, y during the translation. The plus A is referred as moving to the right because you're adding values. Notice that the number line increases here. And if you minus A, you're subtracting the letter A, and that is going in the X. B, if you add B, you're going to go up because the Y coordinate increases as you go up. And if you subtract B, the coordinate for the Y decreases. That's why the general rule is if you add or subtract A, that is referred to your X coordinate because that goes to your left and your right. If you add B, that goes up and down. So this is the general rule for a translation. You're going to use this rule for part B to translate this triangle 4 units left and 3 units down. What are the coordinates afterwards? The 4 to the left means your A is going to be minus 4 because the left is a minus. And 3 unit down is your B is going to be minus 3 because you're going down. If you plug that in into our general formula, it becomes x minus 4, comma, y minus 3. The minus 4 refers to the 4 units down. The 4 refers to the 4 units left, and the 3 refers to the 3 units down. Lastly, you're just going to draw it. So as soon as I move it 3 units down, 1, 2, 3, then 4 units to the left, 1, 2, 3, 4, it goes right here. Notice that the lengths are the same, and the angles are all the same. The side lengths are the same because during a translation transformation, it does not change the object's length or angles. Vocab, vector. A vector is a quality that has both direction and magnitude, or size, and is represented in the coordinate plane by an arrow drawn from one point to another. This is a vector. This is called the tail, sometimes called the origin. The length of it is called the direction, and at the end, there's something called the head. The length of this direction is referred to the magnitude. Vectors are useful because if we go one way, we could call that positive. If we go the opposite way, we just have a negative. The longer it is, the stronger it is. So the length of 5 is longer than the length of 3. This is the core concept. The diagram here shows a vector. The initial point or the starting point of the vector is point P. And I'm going to dot it right here. That is your initial point, IP. And the terminal point is at its end, which is at Q, also where the head is. So that's your terminal point, and this is also referred to the head of the arrow. The vector is called PQ, which is also read as vector PQ. Notice on the top, it has an arrow on top of it. A vector is made out of 2 points on the coordinate plane. The horizontal part, which is this, the 5 units component. This is the horizontal part. And the reason why that is referred to the horizontal part is because that is the left and the right. Likewise, the three units up is referred as your vertical point. because that is your up and your down. If you would like to see this in the component form of the vector, you might see it as this. They have these brackets here, and the first part is your horizontal part, which is here is 5, comma, and 3 is your vertical point. The first example, you are going to identify the vector component in this diagram. You're going to name the vector and write down its components. The vector here is going to be called JK because the J is the starting and the K is the ending. So we call this JK. The first letter is your starting point and your K is your terminal point for the vector. Now you would like to write its component form. So you would have to see what its horizontal part is and what its vertical part is. So let's count. 1, 2, 3 would be its horizontal part because this is 3 to the right. And then we have 1, 2, 3, 4, which is its vertical part. So to move from the initial point J to terminal point K, you move 3 units to the right and 4 units up. So the component form would be bracket 3, comma 4. Next, I would like you to practice and identify the vector component for 3 and 4. Pause the video if you need to. Here are the solutions. 3 is called vector CD, component form 7, comma, -3 in the caret bracket. Number 4, the vector is called ST, and the component form would be caret bracket -2, comma, -4. Notice the reason why this has a -2 is because you start from S and you're going 1, 2, but notice this is to the left, so it's a minus. Here you're going down 1, 2, 3, 4. Why it's -4. Vocab: transformation. A transformation is a function that moves a changed figure in some ways to produce a new figure called the image. Another name for the original is called the preimage. Here you're going to say what the preimage is. The preimage is labeled as A, B, C, and the new image is called the image, which is called A prime, C prime, and B prime. Notice that the image has prime in it. It has these, right? It has these symbols, which is called prime. That means a transformation has occurred, and the preimage has no prime in it. Here's the core concept. A transformation, called the translation. A translation moves every single point of the figure the same distance in the same direction. More specifically, it maps or moves point P to point Q along a vector. The original is P, and it had this coordinate, x1, y1. Now a translation occurred, so there's that vector which moves it. Based on that vector, we add an a to the x and we add a b to the y. Notice sometimes it's also a subtraction. So you're going to now do your vocab and core concept check. 1. Vocab. Name the preimage and image of the transformation. Triangle ABC goes to triangle A prime, B prime, and C prime. Number 2, you're going to complete the sentence. A blank moves every point of a figure the same direction in the same direction. Pause the video and try. Here are the solutions. The preimage is triangle ABC, and the image is triangle A prime, B prime, and C prime. Notice that the preimage has no prime associated with it, but the image does have the prime with it. Number 2, a translation moves every single point of a figure the same direction in the same direction, same distance in the same direction. Example 2, translating a figure using a vector. The vertex of triangle ABC are given there, and you are going to now translate it using the vector bracket 5 comma negative 1. Here's the solution. First, you're going to graph ABC, so you're going to dot these on a graph like so, A, B, and C. Now you're going to use that vector 5 comma negative 1. Let me show you. Notice B here. The 5 is referred as 5 to the right, and the negative 1 is referred as 1 down. Okay, so notice B is going to go 1, 2, 3, 4, 5 to the right, then it's going to go down 1. Okay, notice this is also occurring to the A as well, 1, 2, 3, 4, 5, and down 1. C as well, 1, 2, 3, 4, 5, and down 1. Notice it travels the same distance. Now you're going to label the new image. Make sure you label it as the prime. Example, good? Example 3. Now you're going to write the rule given this. Let's look at how it goes from A to A prime. What does it do? Notice it goes up 1, so this is plus 1. Then it goes to the left, 1, 2, 3, 4. If we go left, we minus 4. Okay, so here we would say that the A, which is referred to the left or the right, is equal to negative 4, and the B, which is up and down, is plus 1. So to go from A to A prime, you move 4 units to the left and 1 unit up. So you move along the vector bracket negative 4 comma 1, or you could write that as the rule as x minus 4 comma y plus 1. Next, practice. You're going to write a translation rule for number 11 and number 12. Please remember it goes from the preimage, which is blue, to the prime image, which is red. Pause the video and give this a try. Here are your solutions. You are going 5 units to the left, then 2 units up. The general form would be x minus 5 comma y plus 2. Number 12. 3 units to the right, 1 unit up. The rule would be x plus 3 and y plus 1. Example 4. Translating a figure in the coordinate plane. You're going to graph ABCD with these vertex and its image after translation following this rule. X plus 3 and y minus 1. Please understand that the x plus 3 refers to 3 units to the right, and the minus 1 refers to as 1 unit down. Let's look at the solution. You're going to graph it, then you're going to apply the 3 units to the x coordinate to the right and 1 unit down. It should look like that. Let me show you how it looks like. Let's grab the C. It goes 3 units to the right, 1, 2, 3. 3 units to the right, then 1 unit down, which is the minus 1. Notice that's how C goes to C prime. Likewise, that is how B, 1, 2, 3 to the right, and 1 down, makes B prime. This is the general rule. X plus 3, which is 3 units to the right, y minus 1 tells us 1 unit down. Here are the coordinates of the original one, and this is how it also looks like. Let's see how it works if we plug it in. Notice that I'm going to show you how we do the calculation. notice that this is the original x and this is the original y. Okay. If we apply this rule, this was -1. We add 3, then the y was 2. 2 minus 1. Notice here, what does that get you? What's -1 plus 3? That gets you a 2. What is 2 minus 1? That gets you a 1. Do you see that? Likewise, let's do that again. This is your x and this is your y. Your x is -1, so if we apply that rule, it was -1. What do we do to it? We add 3, comma, 5 was your original y. And what are we going to do to it? We minus 1. So it becomes -1 plus 3 becomes 2, and 5 minus 1 becomes 4. So this is the prime point. Okay, this is the calculation or the algebra behind this geometry. Lastly, you're now going to practice translating a figure in the coordinate plane. How? This is going to be an error analysis. You're going to describe and correct the error in graphing this image from EFGH after it does this translation of x minus 1 and y minus 2. Pause the video if you would like to give this a try. Here's the solution. Notice that the -1 means 1 unit left, and y minus 2 means 2 units down. Remember, you are also going from the preimage EFGH goes to the prime image F prime, E prime, F prime, G prime, and H prime. So that's the general rule. If we go from E to E prime, okay, this is the rule. +1, because it's actually going 1 units to the right and 2 units up. Do you see how this contradicts with this? That's the error. So the rule that they was stated states that the object moves 1 unit left and 2 units down. We wrote that right here, which is mixed up to this. So what they did is that they mixed up the pre-image and the image. They thought they went from the red image to the blue image, which is wrong. Okay, so that was the error. They mixed up the general rule. Okay, so there you go. Those are all the notes and lecture notes for translation.